Picture this. You're trying to master a new skill, maybe guitar, coding, or even just balancing on a skateboard. You mess up. Again. Your brain screams, "I'm terrible at this." But what if I told you that moment of failure, that exact moment you want to quit, is actually when your brain is primed to learn faster than ever before? By the end of this video, you'll understand why that skateboard failure might be the key to unlocking superhuman learning abilities. But first, let me blow your mind with what's actually happening in your brain when you fail. Here's something wild. When you make a mistake, your brain doesn't just register disappointment. It literally releases a cocktail of neurochemicals that puts you in the perfect state for learning. We're talking about acetylcholine and epinephrine flooding your system, making you hyper-alert and focused on exactly what went wrong. But here's where it gets really interesting. Your brain has these specialized prediction error neurons, basically tiny failure detectors that fire when reality doesn't match your expectations. When you miss that guitar chord or stumble on that skateboard, these neurons go crazy, sending signals throughout your brain. Hey, pay attention. We need to update our model of how the world works. And then comes the magic ingredient, dopamine. But not when you succeed, when you start getting closer to success after failing. It's like your brain's reward system is saying, "Now we're getting somewhere." This dopamine release triggers synaptic plasticity, literally rewiring your neural circuits to encode the new skill. Think about it. Have you ever noticed how you remember your mistakes more vividly than your successes? That's not psychological torture. That's your brain doing exactly what it's supposed to do. Now here's where most people get learning completely wrong. They think more practice equals faster learning, right? Actually, researchers have discovered something called the optimal error rate. And it's about 30%. Let me say that again. You should be failing about 1/3 of the time for maximum learning efficiency. Why? Because if you're getting everything right, your brain thinks it already knows what it's doing. No error signals, no neuroplasticity, no learning. But if you're failing too much, say 70% of the time, your brain gets overwhelmed and can't extract useful patterns from all that failure data. That sweet spot, around 30% errors, that's where your brain gets enough feedback to drive adaptation without drowning in confusion. It's like Goldilocks for your neurons. Not too easy, not too hard, but just right. But wait, there's another piece of this puzzle that most people completely ignore: movement and balance. And this is where things get really fascinating. Your brain has these 4 incredible pathways that connect your vestibular system, that's your balance center, directly to areas responsible for memory, attention, and higher-order thinking. When you challenge your balance, you're not just working out your body, you're literally creating optimal brain states for learning. Studies show that people who did 12 weeks of balance training didn't just get better at balancing, their memory improved, their spatial cognition got sharper, and their hippocampus actually grew in size. We're talking about physical changes in the brain's memory center just from standing on one leg and wobbling around. Here's why this works. When you're trying to balance, your brain has to integrate massive amounts of sensory information, visual input, inner ear signals, muscle feedback, spatial awareness, all in real time. This multisensory integration creates rich neural connections and enhances neuroplasticity. Ever notice how you can think more clearly after a walk? Or how some of your best ideas come during physical activity? That's your vestibular system optimizing your cognitive state. Now, if you're thinking, "This sounds great, but I'm not a kid anymore," Doesn't neuroplasticity decrease with age? You're partially right, but here's the good news. Adult brains are way more adaptable than we used to think. Yes, developing brains have higher baseline neuroplasticity. Kids have these critical periods where their brains are like sponges, soaking up everything. But adult brains? They're more like targeted learning machines. Where kids have diffuse experience-expectant plasticity, adults have focused, experience-dependent plasticity. This means that as an adult, you need to be more strategic. You need to create the right conditions for plasticity. And that's where our failure movement balance trifecta comes in. Adults benefit enormously from incremental learning with manageable failures, especially when combined with physical challenges that engage the vestibular system. Your brain might not have the raw plasticity of a teenager, but it has something better: the ability to learn efficiently when given the right signals. Let's dive deeper into what's actually happening in your brain during optimal learning. When you experience that 30% error rate while doing something physically challenging, your brain releases this perfect storm of neurochemicals. First, you get the alertness cocktail: acetylcholine and epinephrine. These make you hyper-focused on the error margin, exactly what went wrong and why. Then, as you start to improve, dopamine floods in. But not just any dopamine, it's specifically released in your motor cortex and other learning-critical areas, literally rewiring the circuits that control the skill you're practicing. Meanwhile, the physical balance challenge is stimulating BDNF, brain-derived neurotrophic factor, which is like fertilizer for neural growth. It promotes dendritic growth, synaptic strength, and overall brain plasticity. It's like your brain is getting a perfectly timed, naturally produced nootropic cocktail, all triggered by the simple combination of manageable failure and physical challenge. So how do you actually use this? Here's a practical protocol that synthesizes all this research. Step 1. Find your 30% error zone. Whatever skill you're learning, calibrate difficulty so you're succeeding about 70% of the time. Too easy? Make it harder. Failing constantly? Dial it back. Step 2. Add movement and balance. Don't just sit there practicing. Stand on one leg while you do mental math. Walk while memorizing vocabulary. Practice guitar while balancing on a balance board. Use a standing desk with an unstable surface. The key is challenging your vestibular system while engaging your cognitive systems. Step 3. Embrace the frustration. When you feel that frustration creeping in, that's not a sign to quit. That's your brain telling you it's in prime learning mode. The neurochemical release that creates frustration is the same one that drives plasticity. Learn to surf that wave instead of fighting it. Step 4. Chunk your practice. Instead of marathon sessions, use spaced practice. Your brain needs time to consolidate all those error-driven changes. Think 25 to 30-minute focus sessions with breaks, rather than grinding for hours. Step 5. Reflect on failures. Don't just move past mistakes, analyze them. What specifically went wrong? What would you do differently? This reflection engages your prefrontal cortex and helps your brain extract maximum learning from each error. Here's what's really wild about all this. Once you understand neuroscience, failure stops feeling like failure. It starts feeling like data. Every mistake becomes valuable feedback. Every moment of frustration becomes a signal that your brain is actively rewiring itself. Every wobble on that balance board becomes a catalyst for cognitive enhancement. This isn't just about learning skills faster. It's about fundamentally changing how you approach challenges. Instead of avoiding difficulty, You start seeking out that optimal challenge zone. Instead of getting discouraged by mistakes, you start getting excited by them because you know what they represent at the neural level. This principle works across virtually every learning domain. Musicians who practice with controlled errors and physical movement learn pieces faster and with better retention. Athletes who incorporate balance challenges into skill practice show superior performance gains. Students who study while doing light balance exercises show improved memory consolidation. Even in professional contexts, this applies. Emergency response teams that train with realistic failure scenarios and physical challenges perform better in real crises. Organizations that systematically analyze failures and encourage controlled risk-taking adapt faster to changing environments. The key insight is that learning isn't just a cognitive process. It's a whole brain, whole body process that evolved to be optimized by challenge, error, and physical engagement. Now, one size doesn't fit all. Your optimal learning approach depends on your individual traits and circumstances. If you're high in conscientiousness, you might naturally persist through frustration, so you can push that error rate higher. If you're more neurotic, you might need more emotional regulation strategies and lower initial challenge levels. Extroverts tend to benefit more from social learning contexts, where failures can be discussed and analyzed with others. Introverts might prefer solo reflection on errors. The key is to start with the basic framework: 30% errors, movement integration, frustration tolerance, and then adjust based on your personal response patterns. Looking ahead, this research is already being integrated into cutting-edge educational technologies. AI-driven learning systems that monitor your error rates in real time and adjust difficulty accordingly. VR environments that combine cognitive challenges with balanced tasks. Wearable sensors that track your neurophysiological responses and optimize learning protocols. But you don't need to wait for the technology. The principles work with the most basic tools. Just you, a challenging task, and something that makes you wobble a little. Remember that skateboard scenario from the beginning? Now you know why that moment of failure was actually perfect. Your brain, detecting the error between expectation and reality, flooded with learning-optimizing neurochemicals. Your vestibular system, challenged by the balance demands, created optimal neural conditions for adaptation. Your frustration, rather than being a barrier, was actually a signal that profound learning was taking place. The next time you're struggling with something new, remember, your brain is literally rewiring itself through that struggle. Every failure is building the neural pathways you need for eventual mastery. Every moment of frustration is a moment of growth happening at the cellular level. So embrace the wobble, seek out the struggle, find your 30% error zone, and surf those waves of neuroplastic change. Your brain is an incredible learning machine. You just need to know how to operate it. And the most beautiful part? The more you practice learning this way, the better you get at learning itself. You're not just mastering skills, you're mastering the art of mastery. Now get out there and fail at something. Your neurons are waiting.